Very good morning, my dear students. Welcome to Digital World of Pathania Public School. Hope everyone fit and fine in this tough time. In previous lectures, we learned problem solving cycle and steps of problem solving. Today we learn designing algorithm. Designing algorithm. In this chapter, in chapter number 5th, we have learned problem solving step cycle, problem solving steps and substeps, algorithm, flowchart, and pseudocode. This is your basic programming chapter. For any project, you need first to understand this chapter. So today we learn algorithm. Computers are essential problem solving devices. Computers solve these problems by dividing the problems in simple and small steps that are expressed in the form of computer instructions. Computer set of rules that define how a particular problem can be solved in finite number of steps to known as algorithm. Step by step solution of your program is your algorithm. Every program required a solution of the problem, and when you solve any problem you require some steps, and these steps is your algorithm. An algorithm is composed of finite set of steps, each of which may require one or more operation. In every step your operations are written, but there are certain constants to be placed on the type of operation as algorithm can include. Each operation must be definite. It must be clearly defined what should be done. In algorithm, we decide here what we want to do here. For example, again we take same example. We calculate the simple interest. We want to addition of two numbers. So when we addition of two numbers, then we require number one and number two are not permitted as these operations are not clearly defined. Just you write down here add 3 or 8. Here we don't write down the complete coding of your program. Next operation is each operation must be effective. Every step is very effective in algorithm. Each step must be each step must be such that it can be done using pencil and paper in a finite amount of time. For example, arithmetic on integer is effective operation, whereas arithmetic on real number is not, since some values may be expressible only by an infinite long decimal expansion. Each operation must be finite. The algorithm should terminate after a finite number of operations. When you are doing, for example, here we take an instance. For example, um, we want to display the counting 1 to 10. We want to display the counting 1 to 10. So every time your program will be continue till 10 is not there. 1, then again continue with 2, then 3, then 4, then 5, then 6, then 7, then 8, then the last is your 10. So the algorithm should terminate after a finite number of operations. Thus we can say that a good algorithm must be characteristics as listed in the following subsections. And what is the good algorithm characteristics are: number 1, precision; number 2, uniqueness; finiteness; input, output. Precision. Algorithm should be precise, its steps should be precisely defined. And uniqueness, every step should unique contribute to the algorithm. Every step is unique from the each and every. It means that the result of a step is unique and it is only dependent on the input and result of the preceding steps. How is a uniqueness? For example, again we take same example, addition of two numbers. So first we take the value of two number, then we add it. So every step are different to each other. Finiteness, an algorithm must be finite, it must not repeat the step endlessly. The algorithm must stop after a finite number of instructions have been executed. Input. Next characteristics is input. An algorithm requires a specific type of input to work upon. And output, an algorithm produce output as per the stated objective and input it as received. So these all are the characteristics of a good algorithm. If you want to write down a good algorithm, then you follow these all the characteristics in your algorithm. Now next is your components of an algorithm. One must be able to identify where input, processing and output are taking place within an algorithm. What is your input, what is your processing and what is the output in algorithm. An algorithm clearly identifies the following component. Number one is input. The inputs and the type of input requires by the algorithm. How many input you want. For example, if we calculate the simple interest, how many input you input here? We required one is principal, second is rate and third is time. So required three input. We required P, R, T, principal, rate and time. So we input three things, principal, rate and time. The input can be provided by a user or can be self-obtained through such as reading from a file. After that, processing is going on. What and how the processing should use input to produce the desired output. What is the processing? So here we want to find out the simple interest. SI is equal to PRT divided by 100. This is the processing of your algorithm or processing of your program. And the next is output. So what is the output of this? So answer of your question, answer of your problem is your output. The output expected from the algorithm, the objective of the algorithm. If we find out the proper output, then we say our problem is solved here and our algorithm is right. Clear everyone? A program is expression of an algorithm in a programming language. Thus, the success of a problem or program depends upon the algorithm. Your success of the project, your success of the program is depend on the algorithm. If your algorithm is perfect, if you follow all the characteristics of the algorithm, then your program will be successfully completed. Your project will be successful. Therefore, the logic of the problem must be clearly expressed in algorithm. The logic of the problem can be expressed in various manners. One of the most preferred method is graphical method of representing the problem's solution, which is known as flowchart. The graphical and the pictorial representation of your problem is your flowchart. And the step-by-step procedure of your program is your algorithm. Another useful tool for designing algorithm is called pseudocode. In the coming subsections, we are taking about both these tools. In next the lectures, we learn about the flowchart and the pseudocode. Thank you so much for watching this video. We meet in next video with the flowchart. Thank you everyone.